So let's start with the triangle and make perpendicular bisectors. So I'm going to do first just an acute triangle to start, and then maybe we'll look at an obtuse and see what we also get. So perpendicular bisectors are going to be perpendicular to a side and cut it in half at its midpoint. So what I'm going to do first is find the midpoint of one of the sides. And we did this back when we did a mid-segment, another video to check out. So if I match up these endpoints which meet the side, I'm not worried about this stuff over here, but match up those endpoints, it goes all the way down and I can make a full crease on the patty paper. So that way when I open it up, I have this line here, which is in fact our perpendicular bisector. So I'm going to take my pen here and draw this line. So this line is in the midpoint of the segment and also perpendicular. Now it doesn't go through this opposite point, and that's fine. And that's perfectly fine. In most cases, if you did this on their own, it wouldn't work. That would only work in certain triangles. So now I look at this side, do the same thing, match them up, make a crease, open it up, and now I have another line I can draw. Now I have a midpoint and perpendicular. And now for my third one, I'm going to find the perpendicular bisector for my third side. Fold it over so the 2 points meet right here. Come down, make a full crease. Open it up. And I have my third perpendicular bisector. And you notice all three of them meet at the same point. And they should. We actually call that point the circumcenter. So that's the point where all three of them meet, circumcenter. Perpendicular bisectors will meet at a circumcenter. Now what I could then do is if I had a compass, is I can open up this compass so that they all, where I have the circumcenter and the vertex lined up. Let me get a few pieces of patty paper here. And this is actually the same distance to each vertex. So I go here, I can go up here, and I can go down to the bottom one, so they all match up. So even though I use the sides to give me the circumcenter, it turns out it is equidistant to all three vertices. Now, I said I'd look at an obtuse. We'll do one real quick. Remember, obtuse just means it's greater than 90 degrees. Let's try this one here. So I'm going to start with, we'll start with this side down here. I'm going to fold it over so the endpoints meet. Make a fold. And I'm going to fold this side over so the endpoints meet. Make a fold. And we'll do the last one, our longer side. Fold it over so the endpoints meet. And make our final fold. Let's get these other papers out of the way. And I have them meeting right here. Now, so now it's outside, and this is actually going to occur whenever we have an obtuse triangle. The circumcenter would be on the outside. And that relationship we mentioned earlier, where it's equidistant to the vertices, still holds true, because now I could take my compass and see, let's get a little bit larger here, that this distance is the same as this distance is the same as those. So now the circumcenter, even though outside, would be equidistant to all the vertices.